So we're gonna find the first derivative and then the second derivative. First derivative, f prime of x. This is a product rule. First times the derivative of the second plus the second times the derivative of the first, which is 1. What are we going to do? Can we just continue on doing it like that here? Or should we factor something out? Let's continue on, no, like this. Second derivative, so that's the first. Second derivative is going to be, let's do this one, would be the first. It's just the same as that. X e to the power of x plus e to the power of x. And then the derivative of that is e to the x. Is this correct? F prime of double prime of x would equal to, you got 2 of these, so would it be x e to the power of x plus 2 e to the power of x? Yes or no? I hope it is. There's another way of doing it where you can factor it out and do a product rule like that, but I think this should be fine. It's the same as what I had, whereas here we're factoring out e to the x. It's the same answer. Chapter 4, we're moving on to chapter 4, interpreting the meaning of the derivative in context. 4.1. All right, I just updated this. Let me do this real quick here. Sorry guys, let me see. Exit and start over, and I just updated. Hopefully it did update. Is that it? Yes. Yes, let's go. Okay, go ahead and copy this down. Whereas chapter 3 was a lot of computation, a lot of algebra, chapter 4 right here is a little more conceptual. All right, so here, problem number 1, or a chocolate cake is taken out of the oven. The temperature in degrees Fahrenheit, 18 minutes after the cake is removed from the oven, is given by the function p of t. Interpret the meaning of p prime of 10 equals negative 13. Anybody have an interpretation of it? You got something here, Jacob?
Yeah, I'm just getting confused with the words.
Oh, what is it?
I'm just getting confused with the words.
Oh, yeah, I know. It's too much writing here. Like, what do you? Okay, so a cake is taken out of the oven. All right, you take out a cake out of the oven. The temperature is in degrees Fahrenheit. T minutes after the cake is taken out of the oven is given by the function p of t. What is the meaning of p prime of 10 equals negative 13? Anybody?
After 10 minutes, the temperature dropped to 13.
Yeah, okay. So I got something here, and yeah, I'm not the strongest English teacher, and I'm not an English teacher, but a writer. Basically, what you just said, 10 minutes after the cake was taken out of the oven, the temperature of the cake went down 13 degrees Fahrenheit. That should be good. But let's say we have this structure right here. What should go here that is missing? Something after the cake was taken out of the oven. What goes here? 10 minutes after the cake was taken out of the oven. The temperature of the cake is what? Decreasing at a what? At a rate of 10 minutes after the cake was taken out of the oven, the temperature of the cake is decreasing at a rate of what? No, we already said decreasing. You don't say negative. That's a double mean. It's decreasing at a rate of what? 13 degrees Fahrenheit. Per hour. So, oh man. So yeah, it has to be so exact. And we're saying it's decreasing at a rate of 13 degrees, because decreasing is it's already saying negative. 13 degrees Fahrenheit per hour. So a rate is per something. So you always have to say per. You can't just say it's decreasing at 13 degrees Fahrenheit. That's it. We have to say per hour. I guess this should be good now. Let's move on then. Go ahead and copy this. We'll do 2 of these like this. Let's do another one. All right, let's go. Number 2. Here we go. Problem number 2. What's your number? 6. All right. The rate at which people enter a water park in hundreds of people per hour is given by W of T, where T is measured in hours. Interpret the meaning of W prime of 3 equals 4.5. All right, so does anybody have anything here about this? Anybody, what do you got? Here, look, here's one thing that they, it's a bit misleading, because it's already telling you that it is a rate. See right here? This already is a rate. So you would think that a rate would be something like this, because that's a rate of, that's a derivative. So you would think that, but they're already telling you that this right here, as it is a rate. So when they're asking something like over here, is the rate of change of the rate of change. That's what this is saying. All right, so here, let's go ahead and copy this down and let's try to fill it in. At something does something at which people enter the water park is at a rate of something hundreds of people. So let's see. At what? What do we say? At
3 hours.
at time t equals 3 hours. At 3 hours. At time t equals 3. The what? The rate at which people enter the water park is what? What is it? Increasing. Why is it increasing? It's positive. So this is positive. So it's increasing at a rate of what? 4.5 hundreds of people. And now with that part, what do we put there?
Per hour.
Is it just per hour? Do we say per hour? What did I just say? See, this is the key here. You have to understand. This is already a rate. So this one would be per hour. But when you do this now, it's another per hour. So we have per hour, per hour. Huh? What?
Strange.
It's strange?
It's strange.
It's you're describing the rate, which is kind of like describing velocity, which with acceleration. All right, let's move on then to problem 3. A book goes on sale at time t equal to 0. The total number of books sold by time t hours is modeled by the function b that satisfies the differential equation here. Given that b of 12 equals 36, whatever, can't even read it correctly. B is measured in hundreds of books, and t is greater than or equal to 0, less than or equal to 24. A. Write an equation for the line tangent to the graph of B at t equal to 12. Use this equation to approximate the total number of books sold by time t equal to 10. So yeah, we're now getting more abstract with this. And these are the type of questions that you see on the AP exam. So what dBdt? dBdt is the derivative of b. So we are given this. We know this, but we don't know what this is. We don't know what b. If we had been given the b function, then we would just plug it in at b of whatever, no? B of, what is that? B of 10? And then into that function that we don't know though. The only thing we do know is the derivative here. So we got a problem here. So what do we do? Okay, let's go. Write equation of tangent line. Just go straight to that point slope formula. Y minus equals x minus. What we do know is, well, we're not doing this for right now. Definitely, we gotta do this. We gotta write an equation for the line tangent. Here, let's do this. Write an equation for the line tangent to the graph of b at t equal to 12. Let's change some things here. What is x in the context of the problem? X has to be t, no? So let's change x to t. And let's change y to what? Let's change y to what? B, isn't it? Let's go so it makes more sense here. But we're given a point already, no? So what do I put here? T minus what? And then b minus what? 36. How can we find this rate of change here? This m. The slope or the rate of change. Well, we were given the derivative equation here. So we can just go ahead and plug it in because that's the rate of change. That gives you the rate of change at every point on this curve. So we can just go ahead and plug it in for t equals what? For t equals 12. And that gives you the rate of change that you need here. Let's do that. So dB dt is equal to that. We're going to evaluate it at t equals 12. Okay, let's go like 5, 12 plus 4 plus 1 over 9. T is 12 minus 6 squared. Evaluate it there. So what is that going to be? Okay, so it's going to be 5 over what? 12 plus 4 is 16. So it's 5 over 4. And then we got 12 minus 6 is 6 squared, 36. 36 over 9 is 4. We need a common denominator. 4 times 4. So that's going to be what? 16 plus 5 is 20. 16. 21 over 4. 21 over 4. So here's the rate of change. 21 over 4. So there's the equation. Write equation for the line tangent to the graph of b at t equal to 12. So now let's use this equation to approximate the total number of books sold by the time t equal to 10. So now we can go ahead and use this equation here to find b when t is 10. So plug in 10 for t and solve for b, no? Yes, let's do that. Let's move that 36 over to the other side already. So it'll be b equals 21 over 4, negative 2, and then plus 36. Negative 21 over 2 plus 36. 72 over 2. 72, 36, 72 over 2. 72 minus 21 is what? 51. So 51 over 2. What's 51 divided by 2? 25.5? 25.5? So, what does it say B represents here? B satisfies book, book. Total number of books is B. So, it's measuring what? It's measuring what? Hundreds. So then this gotta be 25.5 times 100, no? So go ahead and multiply 25.5 times 100. What is that? So 2,550. So $2,550 books have been sold by then. See, what happens is that we're going somewhere. If we were given the B function already, then we can just like go to t equal to 10, and then figure out what that is, no? And that would have given you 2,550, no? 2,550, but we don't have it, and we're just given this. Let's go to part B. This is part B only here. Let's go to part B and we're done for today. Find B double prime of 5 using correct units. Interpret the meaning of B double prime of 5 in the context of the problem. So what are we going to do? So we have the derivative function here, no? What are we going to do? Find the derivative of it and evaluate it at 5. This is even easier. This is easier than A. So B double prime of 5, this is what we've been doing. Or B double prime of T is going to be, is that move it to the top. Okay, hold on. Let's go. Let's do this again. Hold on. Let's go with 5. Rewrite it where you have T plus 4. No. Let's go. It's going to be, let's put it in radical T plus 4. Put it in fractional exponent. Negative 1/2. Let's go like this. And then plus 1/9. And then T minus 6 squared. That's what, for right now, that's B prime of T. Now we can take the derivative by using the power and chain here for this first part. So it's going to be B double prime of T. Negative 5/2, no? And the derivative of the inside, what's the derivative of the inside? Because we got to take the derivative of the inside. It's just one good thing. They usually give you where it's a chain rule, but it doesn't do anything. And then you're going to minus what? 2 over 2, which makes it 3/2. Negative 3/2, 2 over 2. So negative 3/2 which is going to go back to the bottom. And this is going to be 2/9 t minus 6. 2 minus, and then the derivative of the inside is just 1. And now we can evaluate it at 5, no? B double prime at 5. So 5 plus 4 here at the bottom is 9. Square root of 9. Square root of 9 is 3. 3 to the third power. What's 3 to the third power? 27 times 2. 54. So negative 5 over 54. And then this is going to be negative 5 minus 6 is negative 1. Negative 2 over 9. In common denominator, you want to have 9 times 6, 54. 6 and 6 here. So that's 9 times 6, 54. 54, we have a common denominator, 54. And now we got negative 5 minus 12. Negative 5 minus 12 is what? Negative 17? Interpret this. What does that mean? The rate at which the rate of the book selling is changing, is decreasing by 17 over 54. So this, you got to interpret that is a rate. You're interpreting a rate already. So rate, the rate of the rate. Let's see here, what we got here. At t equal to 5, the rate at which books are selling is changing at a rate of negative 17 over 54 books. So the key here is to say that the rate and whatever, and another at the rate. You're describing the rate. Same as problem number 2 in the interpreting. That is it for today.